Welcome everyone to Physics Weekly, the show where we uncover all the deep dark secrets of physics and expand everyone's knowledge of physics in the physics field. So last week we had a great episode about the physics of the fart and all the forces behind the fart. So now everyone is fully educated in the fart. So this week we have a great episode for you in store. One of our viewers from Southern Kentucky called in and he had a question that was interesting. So we're gonna uncover the secrets of his questions. So everyone, give a big round of applause for Billy Bob, Jim Bob from the Boo.
Billy Bob.
Welcome Billy Bob, Jim Bob from the Boo.
Thank you, Sam Caskey.
So Southern Kentucky must
Yes.
have taken you a while to get here.
Yes, sir. Well, your show runs about every 2 weeks, so
It's Physics Weekly. We run every week.
well, I only get it once every 2 weeks because I'm in Southern Kentucky. But I saw it, so I called, and then I just started running.
Oh, you ran here.
Yes, sir. It took me about a week and a half.
Okay.
I'm a fast runner.
Okay. Well, that's interesting. Oh, okay. So what is your question that you have for us? And how did you come up with this question?
Well, I hunt about, let's say, 5 times a week. So I was sitting up in the stand about last Tuesday, and there was nothing there. No deer, nothing.
Mm-hmm.
Well, first of all, last week's show about the fart.
Right.
Hilarious.
Thank you.
Yeah. Well,
Glad you
I
brought
can't
it.
fart in the stand because it scares the deer away.
Yeah.
They don't like loud noises or nothing.
It's not. I think it's a deer call. I think, isn't that?
No.
Oh.
No.
Okay.
Scare them away. They don't like the smell.
That's understandable.
Yeah.
Anyway.
Oh, okay, my question. I was sitting in the stand and got a little bored. And I was wondering about this bow thing here.
Yeah.
I was wondering, what really is the physics of this here bow here?
Okay. So, that's an interesting question. I mean, obviously the tension forces on the string that allow the acceleration of the arrow to fly forward, which then the inertial forces allow the arrow to come off the string and travel to the target. But I think we can go a little deeper into this. I think we can really uncover the secrets of this bow. So let's dive in.
Let's do it.
Here we are in Billy Bob's house. So we traveled all the way to Southern Kentucky so we could really get to the heart of this, at the heart of where Billy Bob lives in Southern Kentucky. We flew here in about 3 hours. Billy Bob ran.
I ran.
He ran pretty fast though. It only took him about
I ran
12
real
hours.
fast.
So here we are. Oh, Billy Bob, are these your deer?
These here are my deer here that I killed here with the bow. Right here.
Okay.
Yeah.
All right. Well, that's nice. Can you go ahead and draw back the bow so that we can get a clear shot of how this thing works?
Right here.
So first let's start with the basic physics of how a bow works. A bow works with the same way a spring does, using elastic potential energy to do work on something. The moment you start pulling back on a bowstring, potential energy is stored in the flexing limbs of the bow from the work you put in it by pulling it back. The instant you let go of the string, all the potential energy stored is transferred instantly into the arrow, sending it flying towards the target at a very high velocity. In fact, that is why you are not supposed to pull back and let go of a string when there is no arrow, which is known as a dry fire. The energy in your arm transferred into the bow has no place to escape to and stays in the bow itself. This energy is so much that it can cause serious damage to the bow and even break it. So now that we know the basic physics of a non-compound bow, let me explain to you how the compound factor influences what Billy Bob feels as he draws back. In an all-natural longbow, the resistance of the string gets more and more as the bow draws back, obviously because of the elastic forces equation stating that the potential energy will be more the further the string is displaced. However, in a compound bow, the resistance of the string is greatly reduced in the fully drawn back position because of the pulleys on either end of both limbs of the bow. A standard longbow requires nearly as much force to hold it fully drawn as it does to draw it back. However, in a compound bow, once the string is about 50 to 80% drawn, The pulleys reduce the amount of force required to continue drawing the string. This makes the compound bow much more practical and lethal than traditional longbows and is the most popular choice of hunters worldwide.
Welcome back. So now that we have explored the forces on the arrow and how that all affects the impact force of it and the trajectile of the arrow, Billy Bob, is there anything else you really want to explore more on this topic?
I mean, I think so. I think I can find something real quick here.
Okay. I mean, what is there anything else you really were wondering about?
I was looking at my tips the other day and
Your arrow tips.
yes, correct.
Okay.
Correct. I'm not, since I'm from Southern Kentucky, I'm not really the wealthiest man because I'm a deer hunter. I hunt for my food. I can't really afford that much.
Okay. That's understandable.
Yeah. So I was wondering, I was looking at my tips and they're kind of dull.
Okay.
I was wondering, I mean, you can buy the $100 tips that shred the deer in pieces.
Okay.
But I was wondering here, if I can use how dull the tip can be for it to still get a kill shot on the deer here.
So you're wondering, because you don't want to buy the expensive tips.
Correct. I can't afford it.
Okay. Well, if you could, since the bow shoots the arrow very fast,
Correct.
if you could shave down, or not shave, just get lower quality tips.
Yes.
And still penetrate the deer skin. What you want to know what the minimum is, so the minimum amount of money you need to spend.
Correct. I'd love that.
Okay. Well, I think we can help you out with this. I really think we can.
All right.
So let's dive in.
Let's get that deer.
So to experiment to find out the minimum amount of sharpness that Billy Bob's arrow tips need to be, we first need to be aware of the specs of his bow. Billy Bob's bow is shooting the arrow at 303 feet per second, which is 100.5 meters a second, or in Billy Bob's terms, really dang fast. And he's right. 100.5 meters a second is extremely fast, which is why arrows are so lethal. But we're going to experiment to see how necessary the sharp tips of arrows are if the velocity is that fast. So to do this, as you can see me doing right now, I shaved down 6 tips that were originally all the same shape, progressively getting duller and duller.
So here we are back at Billy Bob's house, and here are the finished shaved down tips. So what we're gonna do, we have 6 of them here. We're gonna start off with this one, the most sharp, non-shaved off tip, and obviously it will penetrate the deer, and that will be almost our control sort of for this experiment. And then as you can see, they slowly get less and less sharp until we get down to this last one, which is completely dull, has no point at all. So this experiment will be interesting to see how necessary the sharpness of these tips actually are. Here we are in Billy Bob's very homemade shooting range, and this right here is a shooting target that is used to represent the deer. It has the same resistance that a deer's skin would, so this will be an accurate representation of the arrow penetrating an actual deer.
Billy Bob here. Take one. Sharpest tip we got here. No shaving done to it. This thing's gonna kill that deer real quick.
As you can see, clearly, even though, pretty good shot, Billy Bob. The kinetic force exerted on the target by the arrow is greater than the force exerted on the arrow by the target, so it has clearly penetrated the target, and clearly this tip is enough to hunt with.
Take 2. Second sharpest tip, minimal shaving.
And once again, though the tip has been shaved down, the arrow has still penetrated the target.
Take 3. Third sharpest tip, medium shaving. Much less sharper than the first one.
And as once again, though this tip had barely any sharpness to it, kinetic energy is still so much and so great that it's penetrated it. It's very interesting.
Take 4 here. 4th sharpest tape shaving, and it's heavily shaved down.
Be very surprised if this goes in. Wow, as you can see, I don't know if you heard it, but it made a very loud pop, different than the others. Still penetrated though. Very surprising.
That's a neck shot.
It is a neck shot.
Take 5 here. This tip is ridiculously amount of shaving. Literally nothing there. Look at that. Just take a gander real quick. Look at that. Just think about it. Here we go. Booyah!
Went in. That had no point, no tip at all, and still penetrated. This is prove the point that the velocity is so great on these arrows, it doesn't even matter if you have a point on it. This next shot will really test that though.
Take 6 here. This tip does not have a tip. It's not even a tip.
Absolutely no flat.
Literally just shooting a tip. Nothing there.
We have a $1 bet as to whether this will go in or not. Billy Bob doesn't think it will. I think it will. Wow.
Wowzers!
Billy Bob just won $1.
Oh my goodness, Billy Bob, you are a goat.
So that one had no tip whatsoever. I shaved that down for about 2 minutes, and it still penetrated it. So this proves the point clearly.
I win $1.
That
Billy Bob wins $1.
the kinetic energy of these arrows is so much that it doesn't matter if they have a tip or not, or a sharp tip or a big broadhead, because they will still penetrate whatever you're shooting them at. Isn't that right, Billy Bob?
Heck yeah, that's right. Take number 7. There's no tip on this arrow at all. It's still gonna kill that deer though.
We're just curious now as to see if you even need a tip.
Oh my god.
We have a double or nothing bet. If it penetrates, I will Billy Bob $2. That did not penetrate. That's very interesting. So you do need a tip, even if it's just a completely shaved down one. That's interesting. That right there, my friends, is physics. And welcome back. We're back in the studio. So now we've uncovered the secrets of the forces on the arrow as it comes off the bow, and the when it impacts the deer, what the minimum amount of sharpness on the arrow point tip that it needs to still penetrate the deer. So, surely we've covered it all. Is there anything else you really want us to talk about as far as the bow goes?
There might be one more thing that I...
One, really? Okay.
Yeah.
What is this?
Well, me and my friend Timothy,
Okay.
we were hunting a couple weeks ago,
Alright.
and he hunts with a traditional longbow,
Okay.
which
Can you...
he's kind of poor. Don't tell him I said that, but he can't afford this nice compound bow here, right here, we have right here.
Okay.
He can't afford that.
Okay.
And he was telling me about the archer's paradox.
The what?
The archer's paradox.
Archer's paradox.
It's where he says, I don't know what he's talking about, but he says the traditional longbow isn't completely lined up. The bow and the arrow and the string are completely lined up. So whenever he draws it back and shoots it, it's not lined up. So the bow travels kind of a curve. It like wobbles through the air, but still hits the target where he wants it to.
So you're saying, okay, I've heard of this. Since that bow you have there, the compound bow you have there, is, don't shoot me, is center shot, which means
Correct.
that the arrow is directly in line with the string and the target.
Yeah.
So, in his, what'd you say his name was?
Timothy.
Timothy's bow
Timothy.
is not directly in line there. It's off to the side, but yet
Correct.
it still comes back and hits the target.
Yes, I don't know how, but
Okay. All right. Well, I think we can explain this. I think surely this has a logical explanation.
correct.
So,
Let's hope so.
so let's explain this and let's dive in.
All right, let's dive into that deer.
The definition of a paradox is a seemingly contradictory statement that may nonetheless be true. The archer's paradox comes from the fact that one would think that since the arrow is pointed slightly to the side of the target because it is not in the direct plane of the string of the target, that it would not hit where the archer is aimed. However, it does. This is because of Newton's third law that states for every action there is an equal and opposite reaction. The action, in this case, is the bowstring sliding sideways and then forward towards the target. The reaction is the arrow flexing in direct proportion to the force of the string. It bends in a balanced way to one side and then bends the opposite way and back again and again, decreasing its oscillation slightly each cycle as it flies until it strikes the target. This is what allows the arrow to hit the target. It ultimately bends around the shaft because the string slides to one side and then keeps correcting its flight pattern again and again, creating a straight line towards the target that hits where the archer is aimed. Look closely at this archer and you can see how once he releases the string, it goes slightly to his left and then shakes back and forth after the arrow is released. And then observe how this stiff arrow actually bends back and forth to create the archer's paradox.
Wow, how neat is that?
And welcome back to the studio. That was very interesting. The archer's paradox.
Yep.
I like that. That was nice. So I think time's about up. My manager is giving me this signal.
Deer?
No,
Deer?
that does not mean deer. No, Billy Bob. That means no shooting me. That means time's almost up.
Oh.
So we have to wrap it
Down
up.
in the
So,
boo, whenever we do one of them, that means the deer's in the area.
Okay.
Sorry about that.
Well, it's been good. It's been good, Billy Bob. So, I will.
Well, about that, I'm gonna teach you a handshake real quick.
You're gonna teach me a handshake.
Yep. Here we go. It's from the boo.
Handshake.
A
Okay.
secret boo handshake. All right. Stand up real
Okay.
quick. Here we go.
Okay.
All right. Bear.
Bear. Okay.
Scare.
Okay.
Deer. Make your little antlers.
Okay.
Here. In my belly.
Oh, okay.
Up high. Down low. Too slow.
Oh, wow, got me.
Last one.
Oh. Oh, that is disgusting.
I like that a lot.
Well, thank you.
Thank you.
Thank you for watching. Tune in next week for a special episode about the physics of the sled.
2 weeks for me.
2 weeks for Billy Bob. Big shout out to Mr. Haiducu and the rest of Period 5 Honors Physics at Avon High School. Thank you for watching.
Hola.